Alrighty. Hello, everybody, and welcome to the stream. Hope everybody is doing well tonight. Time Zone, good to see you over there on the YouTube side. RCW, good to see you on the Twitch side. How are you doing tonight? So we are going to pick up where we left off last night. I did a little bit of thinking while we were offline, and came up with a couple of other things that we need to actually change. That we kind of might as well do while we're in here. So we're going to go over that stuff tonight as well, and get into that, and really just hopefully get a little bit further with this refactor. I don't think we're going to finish this tonight, just because of some of the things I discovered offline. But we'll get to that in a second. Before we jump into the stream really quickly, I want to take a second and thank the supporters of the channel. Starting with our elite partners, who are the highest tier of subscription over on YouTube, memberships, and Patreon. That is Javier Alazaran. I'd also like to thank the partners who are the next tier from that. They are Furkan Tokan and Gerboles Inc. And finally, I would like to thank the supporters listed here under the final section. They are a combination of the other tiers of support over on Patreon, YouTube memberships, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated and helps me afford things like equipment costs, hosting costs, just various fees and licensing and that kind of stuff having to do with the channel. So thank you all for that. It really helps me out quite a bit. Okay. And of course, I would be remiss if I did not mention a big thank you to all of the viewers, whether you're here on the YouTube side or the Twitch side, whether you're catching it on VOD or catching it here live. Thank you guys very much for being here. Without you guys, this project and thus this channel would not exist without you. So thank you for being here. That being said, this is an interactive stream. So if you are catching us live, either on the YouTube side or the Twitch side, I encourage you guys to jump in the chat, say hi. If you have any questions, feel free to ask and I'll answer them to the best of my ability. LaFoley, good to see you as well. How are you? Besides, I love the high coffee emotes. It's one of my favorite ones in there. Oh, you have a cold. Oh, that's rubbish. That's no good. I hope you feel better soon. Definitely try to get rest and whatnot, and get your keep your fluids up for sure. All right. So where we left off last time was we were basically looking at just as a quick catch up. We were looking at our resource handler for our materials. And at this point, we've essentially requested all of our assets that we need for that material, and we are now proceeding into actual requisition of resources from the GPU, having to do with our texture maps and stuff like that. So last night we went ahead and we started on our material channel textures, and I kind of filled this out a little bit more and kind of hooked this up just to kind of move us along a little bit here. But this is 90% the same as what we had before. The only difference is we've set these texture maps up with some constants for some indices, and then we hook those up to our materials actual maps. Speaking of actual maps, we did touch on this last night about the shadow map, that should be a global map, and then we also kind of touched on something last night where we had an IBL cube map in here, and I've actually removed that from the material because it doesn't make sense. Here is why. So let's say, for example, that we have, well, you know what? Let me do this visually, right? Oh God, how do I get the dark mode? Hold on a second. Where is it? I don't want to flashbang you guys, but let me see. Preferences. Dark mode. There we go. Okay. So let's talk about why I'm thinking that needs to move, right? So to to bring this all together, the IBL cube map is specifically for the image-based lighting, right? And it's to get sort of a more or less ambient light of the immediate surroundings, right? And right now we're actually using the skybox texture to do that, which is a bit of a hack, but we are eventually going to change that. And so the idea behind it is that we should be getting the sort of ambient light based on the surfaces of stuff that's around us, right? So if we have a mesh here, right, and that is sort of within a much larger room, right, that maybe that room is pink, for example, right, then this mesh I would expect to render with a tinge of pink, right, based off of that. But however, if we had like another room over here that was blue, for example, like the walls were actually blue, I would expect that within there, if we were to draw a mesh, that it would have a tinge of blue to it, right? And so the way that we would accomplish this is we would use what I would call a probe, which would be an object that's basically somewhere in the game world, generally in the middle of like a room, for example, right? And that probe would essentially take a sample of everything around it, right, and render that to a cube map, right? So in all 6 dimensions, in all 6 directions. And then that resulting cube map is what we would use to for the IBL of that particular mesh. So the reason that I bring all this up, let me change this back to blue. I didn't mean to change that one. So if we have, one of those there, and we have another one over here, right? They're going to be different, right? And right now what we have is we sort of have one that is just kind of in the middle of the world, more or less, is what we're doing, right? And it just kind of encompasses everything, which means it's going to be based off of the skybox, and it's not really going to take any of this kind of stuff into account. So it's not as accurate as it could be either. And so eventually the way that we're going to hook this up is we're going to basically get rid of this one, right? Or at least not use the skybox, right? And we'll have these probes that are around the scene that we can use. And if one hasn't been created, we'll use a default one. And that probe will essentially just use data from whatever it was able to visualize at that part of the scene, and we'll refresh it every so often. And it needs to be, it's just a very simple, very low resolution texture, right? It doesn't have to be high resolution at all, because all we're trying to do is capture a very average lighting from everything, right? And so what we'll do is we'll have multiple probes, right? And each one of those probes will be placed probably manually in the scene, according to where the environment might differ. So you might have one probe for outside and then one probe for inside, and you might have, based on different environments that you go into, and lighter rooms and darker rooms and stuff like that, you might have different probes. You might also have a probe that like follows the player around, right? So the player actually is getting realistic ambient lighting at all times, right? So there's a bunch of ways to do this, but the general thing that I'm trying to get at, the point that I'm trying to get at here, is that we should not only should we not be using a single global one, right, but we should be getting that information from the scene as to what IBL map we should be using. And that IBL map should be based off of whatever wherever that particular object is placed in the scene. So, for example, let's say, for example, that both of these cubes in here were both a wood texture, right? If we were to store that IBL at a instance level, that no longer makes sense, right? Because the IBL information for this particular object is not going to be the same as for this object. It shouldn't be, right? We should be able to differentiate that. So we actually need a sort of per object sort of level with this, right? The problem is is that currently the way that we have things set up in our Vulkan render, we have a local scope, but that local scope is using push constants, not descriptor sets. And so we don't actually have a way to hook up samplers on a per object basis, right? And so that is something that we are going to have to add, I think. I was wondering at some point when I initially did it that way if we were going to have to add it, and it looks like we are indeed going to have to add it. Let's see, if you don't want to manually place them, would something like an octree work? Well, an octree would probably be used to figure out like what all which one you should actually grab, right? So an octree would tell us, for this particular mesh, we should be using this one. For this particular mesh, we should be using this one, right? And technically speaking, we don't even really need an octree for that. We could handle it a couple ways. We could do it the naive way and just do a distance-based check, right? And just use the closest one. Or we could have something in our scene that maybe says, well, if we have an object that resides inside of a particular bounding box, right, then we use this particular one. Otherwise, use something else, right? So there's a bunch of ways that we could do this, and probably this bounding box thing is going to be something that we're going to need at some point, because a distance-based check won't work in all situations, right? So you might have, a more crazy situation in terms of room setup. Like maybe we have something like, if I can resize this real quick, I might have to actually draw this manually, but we'll see. What if we actually have, let me delete this. What if we have another room in here, right? And I'm just going to freehand this because it's a little bit easier, right? So we have another room in there, and that room is maybe super dark or lit funny or has something especially different from this particular guy. We might want the ability to specify something like this, as the shape that we want in 3D, where we say, if it's within this shape, then use this guy. If it's within this shape, then use this guy, right? I don't think we're going to have anything that complex right away, but it's something that I'm thinking about. BVH, yeah, that's another thing we're going to look at. Probably not for this first game, but at the very least, however this is calculated doesn't really matter at this point. That is up to the scene and how we calculate that as far as the scene goes. Probably what we're going to do initially is we probably aren't going to worry about much of this at all. We're probably just going to have a single probe in the middle of the level and just use that. Because our first game is going to be mostly outdoors, and so I don't think it's really going to be a huge concern. It's verging on BSP type of stuff, kinda, yeah. And so I don't think this bit, the detection bit, is going to be something we have to put in, but the ability to define different probes, and probably just the distance-based check will be enough for now, right? A distance-based check, if this probe was here, would give us the wrong information in this case, right? Because these two objects are a lot closer together than these two, right? So, we'd obviously, in this particular situation, we'd have to figure out something else different. But yeah, this is what I was kind of thinking about. So, even though these two share a material instance, right, the actual objects themselves use different IBL information. Potentially, right? So I had a note in here that we need to actually move that, and we do actually need to move it, right? But we don't have anywhere to move it to because we don't have any sort of object level, what I guess I'll call object level. We don't have that kind of scope, right? Our only scopes are global, instance, and local for right now. So we'll have to think a little bit about that and how we want to actually do that, right? The other thing is the shadow texture really should be global. Oops. And the reason the shadow texture is going to be global is because that will be for the whole scene based off of where we're rendering from, right? There's no need to have that per instance. I don't remember what I was thinking when I did it this way. Maybe we didn't have support for that at the global level or something. I'm not 100% sure. But yeah, we definitely should fix those issues. So this is kind of what I was talking about when I put in the title, fixing long-standing material issues, because we are sort of hacking these two things into place by doing them at the instance level, and they really don't belong there. The shadow texture kind of worked the way it was because we're applying it more often than is needed, which is works but is bad for performance, right? We don't need to be doing that. And then the IBL texture works because we only have one, but that's also technically wrong, right? So that's what we're going to think about trying to solve tonight, which is a little bit of a detour, but hopefully it shouldn't be too bad. So I hope all that makes sense. Let's see. RCW with a 5-stream streak. Awesome. Let's see. Been meaning to ask, though, how do you do that thing where you edit source in the hover window? Okay, so are you talking in, like, if I do, like, a peak definition here, and then I can edit the source here, and then write it, and then quit out of it? I assume that's what you mean. Yeah, okay. So that is a function of both the LSP. Well, actually, I think it might be... It's a function of both the LSP and... Oh, what was it? I set this up so long ago. Where was that? I don't even remember if it was in here. Yeah, it is the LSP right there. Yeah, so it's essentially running Vim LSP buff declaration. It's going to declaration. That's what I'm using. So that basically pops up that window. And that just gives me another buffer that I can write into. And then I can either quit out of that with just by hitting Q, which I think is like a default key binding. And I think that's it, really. It's that part of it's actually Vim, but it's also powered by the LSP that I'm using. So yeah, I hope that makes sense. Okay. I'm gonna have to go all the way back here. All right. So it opens a new buffer instead of just jumping. Yeah, so it's actually, well, I guess it's technically a window, not a new buffer, right? It'll technically use the same buffer that you have elsewhere, but like, whoops, if I go to definition, it'll open it in a new buffer. If I do peak definition, wait a minute. Yeah, I just realized I looked at the wrong thing. It should be peak definition. I was telling you about go to definition. I meant to actually... Peak definition is what does that. Sorry. That's LSP Saga that's doing it. Which is a plugin. Yeah. I set this up like 2 years ago or maybe longer, so I completely forgot it. But yeah, that right there, if you wanted to like take a screenshot of it or something, that's how it's done. Most of the stuff I have in here is just straight up LSP Saga or Vim LSP. But yeah, it works pretty well. All right. So if we think about what happens here, right? And this was really what got me thinking about this, right? The renderer shader instance resources acquire. So we acquire rather instance resources. So that's instance level resources from the shader itself, right? So we feed it all of our texture maps that we're going to use at that level, and it sets up all of our descriptors and stuff. We basically are going to need another version of this to acquire resources at another level, which we don't yet have. So I believe this is just a pass through to the back end. It is. Yeah, so if we go to the Vulkan backend and we do resources acquire. Oops, that's texture map resources acquire. I want instance resources acquire. There we go. So if we take a look at this, this is essentially assigning our uniforms to each of the sampler states, right? So this is what actually sets up our internal array of texture map pointers, our descriptor states, and all of that stuff. So we would essentially need like another version of this or another level of this per object, is what I'm thinking. The problem with that is we'd have to have some sort of way to store that, right? So the instance state right now is stored in a gigantic array within the shader itself based on the instance ID, right? So the instance ID is just the lookup into that array, and that's where the instance data is stored, all the descriptors, all that stuff. That's where that's held. So we'd essentially need, within that, we would need, I guess we'd call it like an object ID, for lack of a better term. That would work almost the same way as instance states, except it would be object states, I guess, right? And I think it would essentially be the same logic. So we might even be able to like reuse this and just point it to either instance or object, I'm thinking. And then just essentially, move all of this to some sort of internal function and just have this kind of point to it. The other thing is, when we are taking our descriptors into account, right? And I brought up a shader configuration file here to kind of go into this a little bit. So we have our uniforms, right? And then we have our global scope. And then we have all of our individual uniforms here with their type and its name, etc., right? And then we also have samplers, which are treated as uniforms, but they're just a little bit different, right? So we have that for global, instance, and local, right? So we'd essentially just add another section here within this file to handle what we need to handle at the shader level. And then once we parse all of that out, we would potentially have a UBO at the instance level, right, for stuff like this, but also potentially samplers, right, which are each descriptors of their own, right? So we have one, the way that it works is we have one descriptor that holds essentially all of the non-sampler uniforms, right? And then each one of the sampler uniforms has its own special combined image sampler descriptor. And that's the way that works under the hood, right? So the reason that we can't do it in local is because local is using push constants, and push constants they cannot take samplers, right? Push constants are only essentially buffer data, right? We can't, we don't have descriptors at that level, right? So either we would have to convert our local to be another set of descriptors, which would actually break some things. or we come up with another scope that is kind of like local but kind of not, right? Or or maybe we can use local. Actually, now I'm thinking about it. And just have... So we could just have the regular uniforms. We could have go through push constants as they do now. And then we could have samplers, maybe have descriptors of their own at that level. And it would be stored similar to how I talked about before. Maybe that makes sense, right? The only thing is the way that push descriptors or push constants work is they're essentially immediately set, right? Versus descriptors, which are sort of applied and then updated later, and then you can really only update them once per frame. Whereas a push constant, you can update it several times if you needed to, which we use that for things like indexing, right? So we can't get rid of that. So maybe that's the way we do it. Maybe we just add uniform support or sampler uniform support at the local level. Maybe that's what we need to do. And all of this, of course, will be invisible to anything outside the renderer. That actually seems less complicated than having another scope. Right? So then we could just add, we could say, like Vulkan renderer add or acquire local resources, right? And all that would do is essentially set up samplers, sampler descriptors. You're fond of the term actor? That is what Unreal uses. But an actor implies other things, right? It implies that it's like an object that exists in the world, which might not necessarily always be true from the perspective of a shader, because shaders can be used for different things. So like our UI uses these, right? And so for the UI, actor doesn't really make sense. You know what I mean? But I see where you're going with that. So it'd be nice to be able to do, like we would take this IBL cube texture. We'd take that from here and put it here. And then under the hood, we would acquire local resources and pass this configuration. Every time we had to acquire local resources and return an ID just like we do now, for instance. I've already moved shadow textures. That's already been moved to the global uniform section. So really, I guess doing it this way would probably be the easiest thing to implement, I'm thinking. It's probably what I'm going to go with, I think. Thank you for the follow, by the way. Or the couple follows. Thank you. Actor versus entity. Trying to veer away from object. Yeah, exactly. I don't like the term object either. But if I do it this way, if I just make it part of the local scope, then I don't need an object scope. I could just use local. So we could stick with the same nomenclature that we've had this whole time. Which instance I still think is a little bit weird, but like I think of it as material instance. And then we have local, which is like per whatever thing, right? So per entity, per actor, per node, per whatever. Yeah, because we don't really use object. We don't use the term object for anything. Like we don't have game objects, for example. I think that makes sense. I think that's what I'm going to go with. And we're also going to go with ads. Got to pay the Bezos. You know what? Like if it almost deserves the old bleep, I would do that. Like it's see when I say like VS, like you know what I'm saying, right? But the problem is I'd have to bleep out the whole word unless I did like ob. You know, like I'd still have to say like the first part of it. Oh, you mean oh. Yeah, we should censor that too. Also, another one is EC. If you know, you know. From Lake, how's it going? Seeing you, good to see you as well. How are you guys doing? Over there on the YouTube side. Almost done with ads. Then we'll be able to move on. Yeah, exactly. At La Folie, exactly. Yep. Yeah, you would just say EC, or you would say, you know, entity components. And then, of course, every time that, you know, I accidentally say it out loud, I'll just have to be like, anyway. Enough horsing around. I should probably actually write some code. So I think the way that I'm going to do this is probably from the bottom up. So I'll write it into the Vulkan backend first, and then I'll bubble it up to the front end. RCW, you like that effect? That actually took a lot of time and effort to get that right.
It's about 9:03 and 18 seconds p.m.
Wow. Okay. So apparently something with me saying that just made my Alexa just like pick up that I was talking to it. That's awesome. All right. So let's do. I think I can go ahead and grab this. You know what? I'm going to grab the whole function actually. And I'm just going to make a copy of it. And we'll just modify the copy, right? So we're going to say Vulkan renderer shader, and we'll say local resources acquire. And this is going to be a out local ID. And I'm specifically not using rename here because I want to see all the errors that present so I can actually go through and fix them all. I'm going to close that buffer because we don't really need it. All right. So this fix me still kind of applies. We should probably fix that at some point, but I'm probably not going to fix it before the first game. So out instance ID is going to be out local ID. We default that to invalid ID. We look through, and then we have internal max instances. So the way that this works is whenever we create the shader, we have a certain number of maximum instances that we can have. And we can define that in the shader config. And if we don't define that, then I think that default is 1. So we're going to need a another U32, and we're going to say max local count, I guess. It's highly inconsistent, but I might get rid of these max things anyways and just use a dynamic array. But we're going to do that for now. We're going to say max local count. And then we have internal instance states, right? So we're going to need states that are like local states. So let me actually just use this feature, right? So we're going to do the states for all local things, entities, actors, whatever, right? It doesn't really matter. What we want is local states. Now we have this is called instance state. If I go to that, just the name is weird, but like everything else here we're going to need, right? So I'm going to leave that as is. And instead of instance states, we are going to have, local states. And let's see, out instance ID. This is going to be out local ID. So we basically go through, we look for one of those that has been set to invalid ID. And then if we find one, then that's the one we're going to use. We set the out local ID to that index and then break the loop. Then we go ahead and we check the out local ID to see if it's invalid. If it is, that means we have no more room. And this is the part where I'm saying like we might want to rethink about how this is done. But for now, I'm going to mirror the code above and just get it working. So we'll do acquire local resources, fail to acquire new ID for shader, blah, blah, blah. This is going to be max local thingies, right? Super technical term. Max local count. I guess I could say max local count, right? Okay. Now, this assumes that that local states has been created, which it has not been. So we need to do shader creates. And in that, we should have a couple things. So here is our max instances. Our config does not have max instances, so we are actually going to need to add that as well. So let's just do that here for our configuration. The maximum number of local I hate the term objects, right? Thingy is no less descriptive than object. Screw it. Thingy it is. Max local count. All right. So we'll do internal shader. Max local count equals config max local count. Obviously, we'll have to hook that up into our loader as well. And then, let's see. This is global stuff. We can skip all that. Has instance. We should probably come up with a has local too. So where do we determine that? Here we go. So these are going to have to change as well. Do we have... We do have a local uniform count, which is good. But we do not have a local uniform sampler count. Right? So we do need... number of local sampler uniforms, and we're going to call this local uniform sampler count. Local uniform sampler count. And then we're going to say B8 has local is just going to be that is greater than 0, right? Because of the way that we handle local uniforms using push constants, this has local only count if we're using uniform samplers, right? We only need to create descriptor sets for that. So I guess what that's going to be is that's going to be like a partial copy of this block, but renamed for local. So I guess let's put that here, and we'll do if has local, and if using local uniform samplers. Let's see, add a UBO descriptor set. Okay, so we don't actually do that. We just do the add a sampler descriptor set. Okay. So this is going to get the descriptor set count, which at this point will have already been incremented up here. Let's see. Total bindings are 1 for UBO instance if needed plus instance sampler counts. So this is going to be total bindings are local sampler count. And we'll just say that. So we don't need UBO. Let's see. So binding count is UBO count, which is going to be 0, right? So that's actually just going to be local uniform sampler count, right? That goes away. Set config binding count is set right there. Okay, so we allocate that array, which is just going to be that, I guess. Okay. All right, so instance binding index. So instance binding UBO is first if present. So we are not going to have that. We're always going to be binding index 0 because we don't have UBOs here. Set the index where the sampler bindings start. This will be used later to figure out what index to begin binding samplers at. Okay, so in this case, instance uniform count. This is also going to be 0. This is always 0 here because local uniforms are handled via push constants. Okay. So we add a binding for each configured sampler. So again, we need to change this to local uniform sampler count. We don't even really need that if check, do we? Right, because this won't execute if that number is 0. So let's actually just simplify that. All right, now, instance sampler indices. Keeps the uniform indices of instance samplers for fast lookups. Do I need to do that for, yeah, I think I do. I need to keep a list of these for local sampler indices. All right. What did I do it too fast and didn't like it? Local sampler indices. Okay. So we get that. Instance binding index is always going to be 0. That's fine. I'm just going to leave that there so we don't have magic numbers. Uniform array length. Okay, so that can stay the same. Combined image sampler, that can stay the same. Okay. Then we do that. Then we increment the set counter. Perfect. Okay, so this should handle... This should handle our creation of, or at least our structures for to allow us to create those later. I think that should be sufficient. Invalidate global states, invalidate all instance states. Okay, so we need to do this for local states as well. So invalidate all local states. This is still kind of a misnomer, but we might rename that, we might not. This is going to be max local count. Same with that. And then instead of instance states, it's going to be local states. All right. So that is going to allow us to later then say, you know, to know which one of those slots are free and whatnot. All right, call mode, topology types. Okay, so that's all fine. That should do it for the creation. The destruction, basically just need to copy what we do for the instance states for the local states, right? So it's just going to be this. All right, so this is going to be destroy the local states. Max local counts. Local states, let's rename this instance local. Local descriptor sets, nuke that. Okay, local sampler uniforms, nuke that. Okay. Yes, that should be good. And then we go ahead and we nuke the local states array according to max local count. All right. So that looks pretty good. Uniform buffer, we don't need to worry about that. Pipelines, we don't need to worry about that. Okay, I think that's all we should have to worry about in terms of destroying. Create modules and pipelines. I don't think we need to worry about that. This is only descriptor set stuff, right? I don't think any of that stuff is in here. Nope. Shader initialize. Okay, so this is going to be something we're probably going to have to change. Process the attributes, descriptor pool. Okay, so let's see. Does this take into account? We do have a max descriptor set count, which actually I don't think we actually changed that. Set count. Right. This actually needs to take into account we take into account the global sampler count times image count, the max instances times that. Okay, so this, we actually need to add one more thing to this. We could just take this and add it here, and we'll do max local counts, and then we'll do local uniform sampler count times image count. Right, and that line is ridiculously long, so let's actually just do our future selves a little bit of a favor here. Okay. Max UBO count is image count plus... Now what am I thinking here? That's UBO. Okay, we don't need to modify that because we don't have a separate UBO for local stuff. That's all push constants. So max sampler count. Okay, that should get us where we need to be. Okay. So we go through this, we create the descriptor pool. That should now have enough bindings for, or enough descriptor sets for us. Here's all our pipeline creation. We could skip that. Topology stuff, we can skip all that. Global UBO stride. Okay, this is all UBO stuff. We don't need any of that either. Okay, so that should be good. Okay, descriptor set, update, and bind. Hopefully we can tie into that relatively easily. So we'll have to come back to that. Okay, this is apply globals, apply instance, apply local. We're going to have to extend this to do this call here. In fact, I guess since we're here, we should probably do that. Let's see. Apply instance. So we do need a... I could have swore this has a, shader bound instance ID, but I think we don't worry about that on the renderer side. We worry about that in the shader. So we do like shader bind instance, right? And that sets the bound instance ID of the shader. So shaders are actually also going to need a bind point for local. So if we peek definition on this guy, we have a bound instance ID. We also need a bound local ID. Or bound local whatever. Okay. So all this does here is push constants for right now, right? Which is kind of what locals are, right? So instead of all this descriptor set, update, and bind stuff, we were able to just do push constants, and that was it for applying local. But now it's kind of a two-step thing where we have to also do this. So let's take all of this, and we're just going to plop it in here. And change it as we need to. So this is going to be update the uniforms, the, I guess we'll say non sampler uniforms via push constants. And then we don't necessarily want to bleat in this case if we don't have any samplers, right? We need to handle this a little bit differently. What we instead are going to do is we're going to say update local descriptor set if there are local samplers to be updated. If I can spell updated. There we go. All right, so if we don't need the first part of this condition, right? So it's going to be local uniform sampler count is greater than 0. Then we're going to do all this stuff. All right, we've got a double return true there. We can get rid of that. Okay, so let's see. We already have context, so we don't need that. Do we have an image index yet? We surprisingly don't. We do have internal. Okay. So instance states. So this is going to be local data, right? So this is going to be internal local states, and this is going to be bound local ID. And then we're going to rename this to local state. And then instance descriptor set is going to be local state descriptor sets image index. So this is going to be renamed to local descriptor set. Determine the descriptor set index, which will be first. If there are no globals, for example, this will be 0. If there are globals, it'll be 1. Okay, so our check is not going to be quite that simple because we could get away with that, and we still can get away with that for instance, but theoretically we could be 0, 1, or 2 in this case, right? So we could theoretically have a shader that has no globals, has no instance, and only has locals. And so in that case, we need to actually do some checks here to figure out which one we need, right? So has global. Let's do. We can keep that check. We'll add a has local in here. Oops, has instance rather. And this is going to be instance uniform count and instance uniform sampler count, right? And then we will do I guess we'll say if has global, we'll do this. Instead of setting it equal, right, we'll do plus equals, right? And we'll start this off at, actually we'll do equals 0, and then we'll say descriptor set index plus equals that, right? And then we can also do the same thing for has instance. Apotham, how's it going? Good to see you. How's the engine coming along? You and Casey inspire me right now. So I'm building my own pure C engine with OpenGL. Oh, that's awesome. Vulkan is a bit harder than I would like. Yeah. We're hitting a little bit of that right now. It's not too bad, but I also say it's not too bad because it's also something I kind of saw coming a long time ago. The engine is coming along decently. We technically could create a game with it as it stands, even without this feature branch. But it looks like we have an ad starting soon, so I'll try to wrap this up real quick. We technically could create a game with it as it stands right now, but I'm doing a lot of work around resource and asset management for packaging of a release build. And that's also handling a lot of issues like resource ownership and things like that, and simplifying a lot of that stuff, and really just cleaning up the code base, making things a little bit tighter and work a little bit better. So we're doing a little bit of maintenance work. We're adding a little bit of features, just a couple of features before we actually kick off the game, but we're actually getting ready to kick off our first game here really soon. So We're in the middle of a fairly large refactor right now. I would say actually probably past the middle of it. We're probably about 3/4 of the way through it, I would say. And so we're just transitioning to sort of our old resource system to the new resource system and asset system, which have been separated. So, yeah, that's pretty much it. And we have ads. So I'd just like to, for those of you who can still hear me anyways, I'd just like to pause the stream so that nobody misses any content while the ads are playing. Because, we got to pay the Bezos, as it were. Bezos needs his ads, right? Been good. Tried to share your 5 stream streak, but Twitch errored out. Oh, surprise, surprise, Twitch erroring out. I'm not surprised. Sometimes if you refresh, it'll go through. But yeah, I didn't actually see it pop up, so I don't think it went through yet. So I think until you actually click the button, I think if you refresh it, it'll pop up again. But awesome on the watch streak. Appreciate that. So we've got about 30 seconds left on ads, and then we'll crack on. Almost done. All right, cool. Ads are dead. So, what we do, let's see. If there are no globals, for example, we should probably update this. If there are no globals and no instance uniforms, for example, this will be 0. If there are globals, but no instance, this will be 1. If there are both, this will be 2. Okay. All right, so the next thing that we are going to do is this Vulkan descriptor set update and bind. And I think, let's see, local states. This is instance uniform counts. So this is going to, So this should be, do we want to do local uniform count? We need local uniform sampler count, right? But because we're updating a descriptor set, we don't have a UBO descriptor set for push constants, right? So technically these both are going to be 0 for this because they don't actually interact with that buffer at all. I'll have to check this function to make sure it can actually handle that. Okay, and if it fails, then we're going to say failed to update bind local sampler descriptor. All right, so if we go check out this function, UBO offset and UBO stride. Okay. Descriptor 0 is uniform buffer, so we would have a 0 uniform count, which I think wait a minute, let me see. Uniform count is right before samplers, which is this guy. Uniform sampler counts. Let's see. I just want to make sure that I'm not screwing this up. Okay, so we're saying UBO stride and UBO or uniform count should both be 0, and then UBO offset should also be 0. Local state offset. So we actually don't need an offset here because that's a offset into the UBO, which we don't need. Which technically means I think this UBO descriptor state is also not needed. Let's see. No, we do need that. UBO descriptor yeah. Do we actually? I'm not sure if we need that one, actually. Here's the descriptor set that's going to be updated. Let's look in here. Let's look in here and see what we actually do if we access the UBO descriptor state at all. If these numbers are 0. It's been a while since I've written this code, right? So, uniform count, right? So I guess let's just search for uniform count. Okay, so I think that's actually only used in one spot, which is fine. UBO generation. Okay, so this code will never be hit. Let's look at descriptor state. Thank you for the follow. Appreciate that. Welcome. Okay, so that's only accessed here, I believe. Do we access that anywhere else? Yes, we do. Sync the frame number. Okay. That may or may not be a problem. Oh, wait a minute, though. But that's... I think that should probably be updated regardless of either one of these, right? If we have uniforms or we have a sampler count, like that should be updated. Oh, right, it is. It's updated all the way at the end. Okay. Okay, so I guess I am going to need that. If for nothing else, just the frame number sync. Okay. So I guess the next thing is going to be, let's take a look at the UBO stride. So this is actually only used, I think, yeah, it's not used anywhere else in here. Okay, that's fine. Okay, and then I think we're going to be okay. So we would only actually, if we had a uniform count, that's the only time that stuff gets updated. So I think we're good, right? We should be fine with just having samplers only. Which means we should be fine in terms of what our calling function is actually looking for. So as far as that's concerned, that should be all the updates we need there. Okay. I know we still have a couple errors here. I just want to kind of briefly look through this section of code to see if there's anything else I'm missing. Here's the instance, resources acquire. Okay, that's fine. Okay, so back to this. All right, so when we go to acquire local resources, we go ahead and, let's see, we acquire the default resource texture as a fallback in case we don't have something that we need. Here's the instance state, so we need to change this to local states, and this is going to be out local ID, and then I guess we can rename that to local state. Okay, so instead of instance texture count, it's going to be local. Wait, what was that? Instance texture count. The number of instance textures. I don't think we have. Yeah, we don't have this count for local. So let's put this here. And we'll call this local texture count. The number of local textures. Right, so again, it's just scope. Local texture count. Okay, so local states, we just allocate sampler uniforms for here based on the shader's instance uniform sampler count. So local uniform sampler count. Assign uniforms to each of the sampler states. So again, this is going to be local uniform sampler counts. It's going to grab the sampler state. That should be fine. And then this should be local sampler indices. Grab the uniform texture config as well. Config uniform configs. Yes, that should be fine. Okay. Uniform array length. Okay, that should be fine. This is all within the context of the sampler state. That should all be good as well. Okay, I think we might be good as far as that goes. Okay, so allocate some space in the UBO by the stride, not the size. Okay, so we don't need this. We're not doing UBO stuff. Okay, so instance descriptor set index. God, I could have swore we did a lot of this stuff already. All right, let's just rename this to local descriptor set index. And again, this is going to have to check whether or not we have global and instance, right? So it's going to be instance uniform count and instance uniform sampler count. And then we're going to set this to 0. And then local descriptor set index plus equals, right? So we'll increment that by 1 if it has global, and another one if it has instance. Per swap chain image, I think this is going to remain the same. Descriptor set layouts. That one we might actually need to modify. Because I think we only have 2 at the moment. So yeah, max of 2. In fact, yeah, that's going to be a problem. Descriptor set layouts. We need to actually have 3, right? So index 0 is global, 1 is instance, 2 equals local for samplers only. Okay. So here are the layouts. Okay, so all of this should be good. We just need to change this to local. And then down here, we just change this to local. this to out local ID. And this is just giving us a debug name, right? And then we return true. Perfect. All right. So we have that. Now we need to do the opposite of that, which is based on instance resources release. We need a copy of this to release local resources, which is actually just going to be a simplified version of this, right? So it's just going to be local resources release. This is going to take local ID. So this is going to be local states. All right, let's go ahead and rename this to local state. All right, free 3 descriptor sets, 1 per frame. Yep, that should be good. Oh, this should be, that's an out-of-date message. That should be local shader descriptor sets. That also means this is going to be instance. We used to call it object like way early in the series, but we got rid of that because it was nebulous. Okay, so we freed the descriptor sets, invalidate UBO descriptor state. I don't think we really need to do that, but I guess it can't hurt, right? Because it does actually exist, even though we don't actually use it for local state. Fine. Destroy bindings in their descriptor states uniforms. So I don't think this is going to have to change, because this is all, the sampler state is based off of the local state, so we should be fine. UBO state, if the UBO stride is not 0, which it never will be because we don't use the UBO stride for this, so that we can nuke. All right, and that should be good. Okay. Sampler state, try set. Let's see, do we need, I don't think there's any, yeah, we don't need any changes there. There is a bit in here though, Vulkan render a uniform set, right? So when we set a sampler uniform, there was a bit in here that said you can't set a sampler on local, and that's no longer the case. Samplers can only be assigned at the instance or global level. That comment is no longer true. So what we really need to do here is probably convert this to a case. A switch case, rather. So uniform scope. Right, and then we'll do case shader scope global, and that is just going to be doing that. And then we'll do case shader scope instance is going to do this kind of. So we can get rid of this, and we just need to check that the instance ID is bound, right? That there is actually a bound instance, and bleat about it if not. Then we grab the instance state, then we do a return on the sampler try state of that instance state. So the last bit of this is going to be essentially a copy of this, except it's going to work on local instead. Right? So this needs to be bound local ID, trying to set a local level uniform without having bound a local ID first. This is complaining because it's called instance states, because we have instance state here, and because switch cases are weird with scoping. So we need to local states. We need to change that there, and then this will be local states sub bound local ID. Local state sampler uniforms instance uniform sample count. So this is gonna be local sampler uniform. Oops, sampler uniform sampler count. There we go. Okay. So this is the old logic. We can get that out of there. So basically the way this is it first checks to see if it's a sampler. If it is, it checks the scope, and then does the appropriate thing. So for global, we don't have to bind any sort of ID or anything like that. For instance or local, we have to bind a local ID in order to do that for samplers. For any other kind of uniform, we don't have to go through that for local, right? We could just write directly to the push constant block and be done with it. So we're not going to check to see if we have a local ID that's bound or anything like that. Maybe we should. Maybe we should. Yeah, I feel like we should, just for consistency case, right? Like, because that'll make it really easy for us to actually find places where we aren't doing that. So I guess let's just do... We don't technically have to do this, but I think for the sake of consistency, let's do it. Local ID must be bound before setting a local uniform. Okay. So that makes that nice and consistent. Create shader module. This is not important right now. Actually, I think, did we catch everything? I think we might have. I think that's all we need to do. Because we don't have to worry about all the buffer stuff, because that's already all in place. I think that's literally all we have to do, which is awesome. Let's see what this warning is that it's bleating about. Material system. Okay, let's get rid of that. All right. Oh, there was one other thing. Shader. Was it in create? Was it in create or was it in... Let's see. For now, these shaders will only ever have these two types of descriptor pools. So yeah, one's for uniform buffer, one's for combined image sampler. So those are pool sizes. That's fine. I could have swore that there was one other thing that we had to do. Yes. Vulkan descriptor set config is also hard-coded to only 2, and now we actually need a max of 3, because we can have 2 equals local. So there was that. And I think it was also... I feel like we invalidated that somewhere, didn't we? I'm about to literally search for the character 2 because I can't remember exactly where that was. Where we did that. Might not need to, though. Oh, God, that's going to return a ton of results. Yeah, more than 99. Let's not and say we didn't. Okay. Let's have a look at, I think it was instance state, maybe? Was it instance state that had that? Descriptor state? Nope, it wasn't that. Sampler state? No, it couldn't have been that one. No. Let's actually go to definition on that. There was a couple places. Descriptor set config. And descriptor set layouts. That's what it was. Descriptor set layouts we need to change. Right, so let's go back to here and search for that. Descriptor set count. So we might actually be okay because we actually kept this flexible. That's the destruction. Descriptor set layouts. How many? Yeah, we only have a few matches here. So this is when we are initializing the shader. Okay. Descriptor set count. Again, I think we're actually okay because it should just create it however it's needed as we go. Descriptor set layouts, instance set index, and then local set index. I think we're going to be okay. Descriptor set layout count. Just config descriptor set layouts. Okay, I think we're okay as far as the renderer is concerned anyway. So let's go ahead and create the header file equivalents for all the instance stuff. Right, which is only just a few things. So we have the apply instance. The apply local doesn't need to be changed. It already exists. So we have the instance resources acquire and instance resources release. We have the... We're going to have the local version of that. And then instead of out instance ID, it's going to be local ID. And then local ID. Okay. And then as far as the binding, as far as the binding of the actual instance or local, that is all done at the shader system level. So I think as far as the render is concerned, these are really the only two things that we had to add, which is nice. Because now we can go to render types. I think it was types. Thank you for the follower. I appreciate that. Welcome. We are definitely deep into some Vulkan logic here tonight, for sure. All right, let's see. We want renderer types. So let's search for texture resources acquire. That's not the one I want. I want these two, essentially. In fact, I'm actually going to copy these definitions of it instead of the Vulkan ones. And we're just going to sort of plop those right below here. And, oh, I missed an ad break. Totally missed that. Time is flying. We've already had 3 ad breaks. It's crazy. All right. Adrian Hayes, thank you so much for the Prime. I really appreciate that support. Thank you very much. That means a lot. Very much appreciated. And in case you can't hear me because ads were triggered before you did that, I will say it again here in just a second. And this timer is actually kind of off, so I'm just going to manually cut back over once ads are done in about 10 seconds. All right, and the ads are actually over. I triggered that a little bit late. Yeah, Adrian, thank you so much for the Prime sub. I really appreciate that. Thank you for the support there. Very much appreciated. Okay, so so these two guys are for our local resources, right? So we'll get those in here, and then we'll have instance. So we'll just replace that with local in both of these cases. Pointer to the backend interface. Okay, I just want to make sure my comments are correct. They should be, except for this guy here. Pointer to hold the new local identifier. And then this is going to be out local ID. And then internal local level ID. Okay, this is going to be the local identifier. And then local ID. Perfect. Okay, so we can take these now, go to our renderer front end, which I'll do the header file first. And then right after here, we will change the format of these to match what our renderer front end does. Right, so these ones wind up getting exported. So that's the first thing. They are also not function pointers here. They are actually named regular functions. Okay, that should be it as far as what's required in the header file. And now I'll take these over and put them in the front end C file, which is going to go right here. Right, and obviously I'll just get rid of this. We don't need the export symbol there. Turn this into function there. Oh, I see a mistake I made. Okay. This actually should not be taking a pointer to the back end. It should be taking a pointer to the render system state, right? So this should be render system state So that's going to be the same case here. And then this is just going to be state, and the same case here. And then I'm just going to copy this comment and replace that and that, right? We need the render system state to be passed through. So this is going to be the render system states. Again, we'll make that same change here. States. There we go. Okay. Interestingly enough, it looks like we converted these functions here to take in the state pointer, and then we just never actually updated this to not use this static function to get it. So this should just be, oops, state backend, state backend, state backend, right? And then all we need to do here is I'm actually just going to copy pasta this again because it'll just be quicker than typing the whole thing out. So this is just going to be local resources acquire and out local ID. And then we'll take this guy, right? And this just points to our interface that we have 8s local and local, okay? So the front end just passes that request over to whatever backend is hooked up, in our case, Vulkan. And the only other thing I need to do is hook up the function pointer itself, which is in the plugin main. So if we take a look at the acquire and release for, oh, not texture resources, instance resources, we can copy these two lines, pasta them here, and we'll just do local, and then I wonder if I could just make Vim redo that. Ha, it did. Okay, cool. All right, so now our function pointers are hooked up, and we have all of that wired up to the front end. So now the other half of this involves the shader system. So the shader system is actually not going to have to do that much. It's mostly just a pass-through, but there's a couple things that we need to bear in mind. So let's see. We have, I just need to refresh my memory on where all this stuff was. Okay, so we have bind instance. So we're actually going to need a bind local. So we'll say binds the local with the given ID. Must be done before setting local scoped uniforms. This is going to be the identifier of the local to bind. And then we'll do local here and local ID here, right? So we have that. And then apply local actually doesn't change from a interface perspective here. Most of what happens here is on the back end. We do also have, though, the shader system shader instance acquire, right? So we actually need to hook up those renderer functions to these guys as well. So we do need to create those. But again, it's mostly just the pass-through, right? And what this will do is this is sort of a shortcut to what we were having to do in the material system, where we had to create all that configuration, pass all the texture maps and all that stuff, and pass that through the renderer. This offloads all of that work onto the shader system, and so the shader system can just be like, or anything else that's using this rather, can just call this and it's a lot easier to deal with, right? So we have out local ID. So we'll say local resources, and this is going to be local ID right there. And then again, this is going to be releases local resources. The ID release local resources for. So I missed one up here. And here. And here, actually. Okay. So instance to local. Okay. Thought I was missing one. Right there. Okay. So instead of instance ID here, this is going to be local ID. All right. And then probably what I'm going to do, more than likely, is I'm actually just going to go here. Maybe. And see, we have all this logic, right? And I really don't want to repeat all of this logic. I don't think I need to. I think I can probably generalize this, make a private version of it, and then just flip a switch as to what we're using, whether it's instance or whether it is local. I'm going to start with a release, actually, because that's easier. So release is going to be, first we'll change that to local release instance ID. Okay, if we get the shader, we release texture map resources. Okay, so that shouldn't change at all. And then we release local resources for the shader. Wait a minute. Yes, okay. Yeah, that's correct. Okay, so we need instance ID and then instance resources release. Hey, McGetsub, how's it going? Good to see you. Welcome, welcome. Okay. Fail to acquire render resources for shader. I'm going to put in here local render resources, and this should probably have instance render resources in there. Error message. Okay, so these are like 90% the same. The only real difference is this. And obviously this string here, right? So I guess we could, in theory, we could just, branch on that to avoid repeating ourselves, right? So I guess I could just do it this way. And we'll call this, we'll call this static, right? And this is just going to be instance or local release. And then what we'll do is we'll say just ID, right? And then before any of this other stuff, we will do we'll do shader scope, which would be our switch, right? So we'll do selected shader by shader ID. That can stay. The releasing of map resources can stay. And then we can do if scope equals shader scope instance. Then we'll do this, right? Else if scope equals shader scope local, then we'll do this, which I realize is still kind of repetitive, so we'll fix that in a second. All right, so we're going to have B8 result equals false. We'll set result here. We'll set result here. And then here, we'll say %s, and as a second parameter, we'll say scope equals shader scope instance. Whoops, shader scope instance. Then we'll do instance. Otherwise, we'll do local. And then these will both use just ID. And what did I do? I put an extra equals sign in there. Get rid of that. Okay. So we go ahead and do the result. Also, we're going to say else. And then we're going to do a k fatal. And I'm doing a fatal here because, and you know what? In fact, I'm going to do better than a fatal. I'm going to do an assert. And I'm just going to say false. And I'm going to say global shader scope should not be used when releasing resources. And the reason I'm doing that is because that'll immediately trigger a breakpoint, but it'll only happen in debug builds. Which is fine, because on release builds, we'll know that we'll never hit that, right? Because we will have tested our game in release mode, or in debug mode, rather. And the only difference is that flag that gets passed, right? So this will become a no-op, essentially, in a release build, which is fine, right? So, if not results, okay, so that's good. And then we return result. Okay, so now what this allows us to do is I could just do I can call this, return that, pass the shader ID, pass the scope, which in this case is going to be instance, right? I can pass the instance ID, instance ID, there we go, map count and maps, right? And then all this other crap can go away. Far less repetitive, right? And then I could just take this, go here, paste that, change this to local, and change this to local ID. Boom. Spammer. You are banned. All right. So I got that. That'll just pass through to the renderer, and we should be good to go. All right, so the next bit of this is doing the same thing for the acquisition of resources, right? So that's going to be a little bit, it's going to be a little bit more complicated, but not anything terrible. So let's just have a look at what this is doing. So we're creating a resource config. And then we're getting a sampler counts, right? That's all pretty generic stuff. Uniform config counts. That's of the configuration. We're setting that to instance sampler count, right? Which is, let's see. Instance sampler counts. Let me clear this highlight. So we set up the instance sampler counts. Uniform configs based off of that. Create a sampler config for each map. Okay, so, and then the only thing is this requires, this calls texture map resources acquire, and then it also calls instance resources acquire, right? So we'd have to switch here based off the shader type, or sorry, the uniform, I keep saying the wrong thing, the shader scope, right? So whether it's local or instance, right? And then everything else is pretty much the same. So we can actually take this and make it into a sort of little bit more generic version of this function. So let's do that. And I'm just going to paste a copy of it right here. And we're going to make this static just like we did below. And we're going to do, let's call this instance local acquire. And just like before, we have the shader ID. We're going to take shader scope here. Just call that scope. And we are going to say out ID, right? Because it could be either instance or local. So out ID is sufficient. All right, so we go ahead and select the shader. Let's rename this to, let's just call this, I guess, config, right? Are we using config anywhere else? I don't think so. So we can just call this config, and then sampler count. Okay, so in this case, this looks okay. Uniform config counts. We should probably do some zero checking here at some point, but I'm just going to convert the code for now. So we loop the samplers, or we loop through the maps and create the sampler configs, right? So that should be fine. Let's see, is there anything in here that is specific to instance? I don't think there is, other than, well, actually even this isn't specific to that. The only thing that actually is this guy. All right, so this is going to be the same thing. So we'll do b8 result equals false. And then we'll do if scope equals shader scope instance. Then we'll do that, right? And then otherwise, we're going to do result equals renderer shader local resources acquire, state pointer renderer, selected shader, and then config, which, yeah, I need the address of that because that's a pointer. And then we're going to point this to out ID, which needs to also be done here. Okay. So based on that, we'll also, oh, you know what? This should be an else if. Scope equals shader scope local, right? And then we'll have an else here. And we'll do, again, a k assert message false. And the message will be global scope global scope does not require resource acquisition, you dingus. There we go. And that's actually going to prompt a return false. Not that it really matters because we assert anyways. Okay, so at this point, if we fail that, then we're going to say we failed to acquire. And we're going to put a string in here. Which actually, I just thought about this. Did I have these in the wrong order. That would have been really confusing later on. Thank you for the follow. Appreciate that. Welcome. Okay. Let's see. Where were we? Here. Okay. So the first string here is going to be it's going to be scope equals shader scope instance. We'll pass instance. Otherwise, we'll pass local. And we can guarantee that those are the only two cases because of this. All right. So then we clean up the uniform configs, and we're done. So this function now becomes a call to this guy. Yoink. So we return the results of that. So we have shader ID, scope, we're going to have to define, right? So in this case, it's instance. Map count is there, maps is there, and then we pass along out instance ID here. And then the local version of that is almost a carbon copy, just slightly different. Right, so this is going to be out local ID, and then this is going to be local. Easy peasy. Okay, so we have that. The only other thing that we need, I think, now is just the bind, which I believe we also, yeah, we added the header function for it, just not the actual definition. So this is going to be actually the guts of this are basically going to look like this. So let's just go ahead and do that. It's going to be local ID. Cannot bind shader local ID, invalid ID, right? So we make sure that we don't pass invalid ID there when we go ahead and bind. We always want to make sure that we have a valid ID. And we need to change the bound local ID to local ID. And that's where that binding happens. So when we go to actually apply the local or global, that is where that binding occurs that we then later look up in the Vulkan backend so that we have that ID that we need. After school, over on the YouTube side. Hello, how are you doing? Welcome. Hope everything is going well. All right. Trying to think. I believe that's all we need to do to add local descriptors for our samplers. Let's see. So when I build, yeah, we've got some errors in here, but I think this is the other stuff I was ripping apart. Render type utils. Eh? Render type utils. Duplicate case. Oh, right. We don't have terrain types anymore. That's why. Okay. Oh, still in that file. There's one more issue. So I need to remove these two lines. Okay. Now we're back to the material handler, which is what I expected to be erroring. What is it? Handler material. Wait. That was the... Oh, it's the resource handler. There we go. Okay. So, the cool thing about what we just did is it also actually allows us to get rid of all this crap. This becomes actually way simpler to do. Because we don't have to set up this configuration anymore. We can actually just use our shader system to do that. So we have our instance resources acquire. So what this actually becomes, I'm going to take, how do I want to do this? I think I'm going to write this code here above all this stuff. So we're going to do shader system. Instance acquire. Okay. The shader ID is going to be state PBR shader ID. I don't know why that's failing, but okay. Fine. Okay, so map count in this case is going to be 3. The texture maps, right, is going to be just these guys. So what we can actually do is we can actually just create a quick array of these guys. So we can do what I should have done. Oops. What we can do is do k resource texture map pointer array 3 equals that. Probably screwed that up. Let's see. Oh, I didn't give it an identifier. I guess let's call this material maps. Fine. And then M. Let's see. M is going to be, yeah, we need this up here. Right? Okay, so states, is it
Is it state pointer? Yeah. No. Wait a minute. Where is the... Oh, I'm going to have to get it the hard way. Okay. Let's do... I need the shader system. Actually, I don't even have to do it here, I think. I could just do... Oh, wait a minute. PBR shader ID. We don't actually have that here, do we? All right. I'm going to create a local variable. U32 PBR shader ID equals shader system get ID. And I think we're actually doing, weren't we doing this down here somewhere? I guess not. It's going to be, what was the name of it again? What was the name of it? I think it was PBR. Let's see. Oh wait, this is under runtime, not the game. Shadow underscore static mesh. No, that wasn't it. It was PBR underscore static mesh. That's what it was. PBR static mesh. All right. And I just realized this actually isn't going to work until we actually redo our shader system to actually use those resources as well. The new resource system. Which is fine, because this code will just work with that. Okay, so we have the ID. The maps are there. And then the instance ID, we are going to store in the, let's see, where were we actually storing that before? I guess it's part of the resource, right? So it's going to be, the M instance ID, right? And we're going to need the address of that. Use of undercloud identify. Oh, it's material maps, not just maps. What's it bleating about? Oh, I guess it doesn't want pointers to it. That seems wrong. Should be taking pointers to those maps, not... So we just have this. When we create our configuration, oh, we're taking the address here. That's wrong. I'm actually surprised that ever worked. It should. This should be an array of pointers, right? Which means that this should also be an array of pointers, because we want pointers to texture maps, right? Because that is actually what winds up getting used or stored in the actual in the renderer, right, as a pointer to that texture map. And we were taking basically the address of a local variable, which is, I can't believe that ever worked. I don't know if it actually ever did. Shader system H. So that was just a nasty typo. So shader instance acquire, and local acquire. And then this should be an array of pointers to instance texture maps and an array of pointers to. Okay. That makes a whole lot more sense. Okay. I guess we need to go back to our material handler. All right. So this now should return a Boolean, I believe. Yes. So we need to make sure that that's successful. If that fails, that's obviously a problem. So in this case, I think I already have an error message that I'll just use. And I believe this is just actually it's a return void, so there's not really much to do about it. Let's do an assert message. Right? That'll trigger a breakpoint if that happens. Thank you for the follow. Welcome. Hope you're doing well. Let's see. Alex Lee over on the YouTube side. How are you doing? You're working alongside on Ray Trace Shadows. That's awesome. I can't actually wait to get into that, but that's probably not going to happen before we release the first game. To be honest, it might not actually happen until we have more than one rendering backend, just because I'm going to want to implement that in a API agnostic way. Okay. So, unless I am missing something, which I don't think I am, this logic here replaces most of this down here. Before I nuke that, though, I do also want to handle... Well, okay. So we need to actually convert this to local, right? Local resources. However, I don't have that at this juncture, so I actually can't do that. This will have to be handled whenever we acquire a material. So every time we acquire a material for use, we're probably also going to have to acquire that sort of local ID. I think that's going to be the best way to do it. Because every time we acquire it, we're going to be using it for a separate sort of object, right? So yeah, actually, let's do this. We can get rid of this. The shadow texture is going to be a global map. I'm going to leave the comment here just because it's like still a to-do. And so is the IBL cube texture. But we now no longer need to do any of that stuff, right? And so technically speaking, all of this is going to be moved out of here as well once we figure out where that needs to go. So all of that configuration and stuff that we had, now because of the way that we've set up our shader system, all we really have to do is just this, right? Which is much easier to work with. Okay. So, I guess the next question is, what do we need to handle next? Because I don't really want to... We should... I don't like these magic 3s all over the place. Right? These should probably be... Actually, don't we have a... Let's see, sampler indices. We actually don't need this anymore. Wait, or do we? That might actually not be true. Index. PBR. Oh, SAMP index. Yeah, they're not used anywhere. Okay, perfect. So we can get rid of that. Don't need that. All right, PBR material channel count. That is the one we want, right? So down here, where we have this, it should just be that, right? And then that's going to be, oops, that needs to be there. That's also going to be used here. So PBR material channel count, and also here. Okay, and then that way, whenever we get around to adding the emissive map, which is going to make that number 4, then this stuff will kind of just break, right? And we'll know what we have to fix. Okay. So now I have to think about how I want to accomplish this bit and this bit. Obviously, when we're loading up a resource, a material resource, right? We don't need to handle globals there. We need to actually move. We need to move this. I think that's going to be. That's going to be. Whenever we load the material shader, or the PBR static mesh shader. Let me think. So whenever we do that, whenever we're setting that up, which I think that's all owned by the forward render graph node now, I believe. Yeah, here's where we get all the uniform locations. Right, that's what all of this is. So our shadow textures. Shader PBR material. You know what? I'm gonna change this. I know this is technically correct, or it will be for our new asset system, but since our shader system still works the old way, I'm going to use the old name for it. Okay. So I think the shader system is actually what needs to do all of the loading of all the global resources. So actually, we shouldn't even need to do this at all. That step's totally unnecessary. So, the only other thing that we'll have to do in here is whenever we're actually using that, we'll have to change how it's used. So, we have shadow textures. Which all the shaders are probably going to have to be changed to do it this way, but that's fine. Okay, so shadow maps. This is set by location. This is actually global though, so I guess let's take this, right, and bring this out of this area, because this is for each individual water plane at that point. There's going to be a few of these. And it should be up here with our globals, right? So, oh, you know what? We haven't done this for the water shader yet, though. This is for... Yeah, let's not move this one yet. We need to move... Not that one. Okay, that's the terrain one. I don't want to do that one yet either. PBR shader ID. Here we go. This is the one. So right now this is being done as part of the instance, and it should not be. So let's see. Here we have the bind instance. Here we have the apply global. So it technically needs to go before the apply global. Right? So we can set that. We could set that uniform. And I think that will still be okay. So we should be able to set that uniform. We need to set the uniform, rather, for the shadow maps before we actually apply the globals, right? Because that's now a global. And I think that's the only thing we actually have to change for shadow maps for the PBR shader. All right, so the other thing here is this IBL cube texture. And this is what's going to use our new local level stuff. So what I'm thinking for this is we're going to have to handle this, I think, in our actual material system. Which means our material system is actually going to have to change up a little bit. So right now what we have is we have our material system acquire, right, where we provide some name of a material. And then we sort of request that resource, right? If it's available, it will immediately return here as available, right? And that's fine. And then it'll just return, sort of that resource, right? If it's not available, then it'll be marked as, hey, we're still loading this thing, but here's a pointer to what eventually will be the resource. So this is actually going to be where we're going to have to put that logic. And we're going to actually have to change this. First time chatter, welcome over there on the Twitch side. So we're going to actually have to change this to take a U32 pointer to a, we're going to call this out local ID. So this is going to be a little bit unique to the material, but I think that's fine. Oh, you know what though? I just had a thought. Yeah, no, there's only an, okay, all right, no, we're good. All right. So what we're going to have to do is essentially yeah, this gets complicated. Okay, so here's what gets complicated with this, right? So this resource request here is to be thought of as asynchronous, meaning we kick off a request that will be returned at some point, right? We are returning a out resource, right? A pointer to a resource, but this resource has a state, right? Right here. And that state can either be, uninitialized, initialized, loading, which is more than likely what we're going to hit if we immediately check it, or loaded, right? And so loaded basically means it's ready to go, it's ready to be used. Anything other than that, you basically can't use it yet. You need to fall back on some sort of default. So if this resource is immediately available, right, meaning it's already been loaded, we're actually requesting a second sort of copy of it, if you will, or a second reference to it, then we could go ahead and acquire local resources. If not, that local resource acquisition is going to have to wait until the resource itself is actually loaded and ready to go. So and also the way that this is handled is, resources are based off of these k-names. So if the resource is just found by name, it will immediately be returned from the resource system. So it doesn't even go through like a handler or anything like that. So I can't even really split it up that way. So if the resource is already loaded, then new local resources from the shader, it is associated with, must be obtained here before returning. If the resource is not yet loaded, then this should happen when the resource is finally loaded. This means the pointer to the local ID will need to be passed along in the context of the request. Which I'm not a huge fan of. But it's the only way that I can think about it working. So we'll stub this out. We'll say if out resource state is equal to k resource state loaded. Then we're basically going to do, I'm going to copy this, but we can't use it exactly like it is. So we need to do to-do get shader ID from material. Vim enjoyer pog. Yes, I am a Vim enjoyer for sure. We are about to have ads. You know what? I'm going to bat away the ads for a minute. Welcome, by the way, as first time chatter. Welcome, welcome. All right. So this is going to be shader system local acquire. And then we're also going to have to know, we're going to actually have to get a, that's a little bit more complicated, I guess. I guess we're going to have to do material out resource. Oh, I guess I need typed resource, don't I? Okay. Let's do typed resource equals out resource. Right, so we can do typed resource. And how are we going to do that, actually? We're going to have to look at the material type, I guess. Okay, this actually gets a little bit more complicated. So I guess we'll do, because this is actually going to hinge off of that type as well. So we'll do if typed resource type equals k shader k resource shader. Do we not have what is this type? K resource material type. That's what I thought. PBR. All right, so if it's PBR, we'll do this. All right, so we'll get the PBR shader ID. I guess actually it's safe to make that assumption. And then for this, we will do, we have 1, right? And the material map is going to be the address of. Thank you for the follow. I appreciate that. Let's see. I use Vim at work because my mentor does, and never looked back. We both now use Helix. If you've heard of it, I have. I tried using it a little bit, but like the backwards way that it handles like selection versus editing just throws me. The LSPs were easier to set up in Helix than NeoVim, and we're too lazy to fix it, so we migrated. Fair enough. Nice to meet you too. So we are working on a game engine from scratch, actually. Written in C and rendered using Vulkan for right now. Actually, let me just actually pull this up because I know there's been a few new people that have filed in. So we're actually getting ready to wrap up the stream for the night, but I'll just give you kind of a quick brief of what we're working on. So I'll drop a link to this. So this is the main website for the project. So we're building a game engine in C using Vulkan as our initial rendering backend. I say initial rendering backend because we plan on supporting Direct 3D as well as Metal as well. And so that's going to be all configurable by the application, and the application can choose, what it wants to use and not use via a plugin system that we have. But I digress. This. Let me just bat away the ads again. Okay. This project is built, it started off as a sort of like a YouTube tutorial series, but we quickly outgrew that format just because, a tutorial can cover like how to make a basic renderer, right? But like once you get beyond that point and you start building all these systems, and the code base grows, like it really doesn't work anymore. So we changed formats to a couple of different things. Ultimately, we landed on this live stream format. And then, so I've got links here to the YouTube channel as well as the Twitch live stream channel. The engine itself is open source, right? So it's available on GitHub. And here it is, right? So it is open source and free. So it's Apache 2.0 license, which means that if you want to use it, you are free to do so, whether it is personal use or commercial use, does not matter. All that I ask is that you say you used it. That's literally it. And so there will never be any sort of licensing or royalty fees of any kind ever. This engine will always be 100% free. In addition to that, it is multi-platform. So it does currently support Windows, Linux, and Mac OS. We have other platforms planned in the future, but for right now, that's it. We have some other links here. Again, the YouTube and Twitch channel. We have our Discord server here, which is just under 1,000 people at this point, I think. Might actually even be 1,000 at this point. A link to the GitHub, and then a Patreon if you're interested in that. And then, of course, we have the live stream embedded here at the bottom, so I can wave at myself in perpetuity. Inception, yay. And so, yeah, that's basically what we're building, right? And actually, I've got some old screenshots here on the repo. We are eventually going to update these because these are, like I said, a little bit out of date. But we have a basic PBR pipeline with, just a material system, cascading shadow maps. We actually have water rendering as well. It's not actually on this screen, but if I were to flip over to the ad screen that I use, you can see it there. Just a render of that, what that looks like there. So I'll just turn that off because we're not actually triggering ads right now. I just wanted to show you that. And then, we have the ability to, manipulate objects around the scene. So we kind of have like a world editor sort of thing, at least the starting of one, where we can, manipulate objects with a gizmo and move all that stuff around. We've got UTF-8 text rendering. We have a basic UI system, at least the start of one. We have to build a lot more controls out, but we're also building that from scratch. And so, yeah, there's a lot more information here on the GitHub in terms of, how to actually pull it down. We are in the middle of a pretty large refactor now and handling the way that resources are handled within the system and the way that assets are handled. We wrote completely new systems for that, and now I'm converting all of the other systems that rely on that in the engine over to use the new resource system. So that is basically what we're in the middle of now. We're in the middle of refactoring the material system to use that new resource system now. So that's what all of this stuff that you're seeing on the screen ultimately is. However, I do have to work in the morning. So what I'm going to do is I'm going to save this and we'll pick this up on the next stream. I may actually wind up doing a little bit of work off camera just to kind of push things forward a little bit, because some of the things I have to do are kind of monotonous and not very interesting to watch or discuss. So yeah, I hope that helps and gives you a good introduction as to what we're doing. All right, so with all that said, I'm going to find somebody to raid. And let's see. Let's go with... You know what? Let's go with... I don't know if they're actually working on... What are they actually working on? Let me check and see what they're working on first before I... maybe not. Okay. Yeah. I'm looking for something that's kind of related to what we're doing. Let me just have a quick scroll. I think I know who I'm going to actually raid, though, but I just want to kind of go through here and see if there's anything that's pretty close to what we're doing. All right. Let's go with... I actually haven't rated him in a while, so we're going to go with... where did he go on the list? I'm just going to search. We are going to raid Jitsbo. He's working on a retro FPS. That's pretty sweet looking, actually. And I would say ask him to demonstrate throwing books at things, because it's a pretty hilarious mechanic he added to the game, and if he's able to, he'll probably demo it for you. But yeah, that's going to do it for tonight. Thank you guys so much for being here. I really appreciate you guys. If you haven't already, I would really appreciate if you toss me a follow. It helps me grow the channel, whether you're on the YouTube side or the Twitch side. Either or helps, or both if you're so inclined. But yeah, we will catch you guys on the next stream. So I'll see you guys later. Thanks again for being here, and see ya.